Right, grade 12, Mr. Oosthuizen here with question 11 from paper 1, September 2014. This question was in general very badly answered. So let's look at this question. We have here a given square and then this rectangle inside with these lengths x given, and therefore we need to work out the area of this rectangle for the first question. Now for the area we need the length and the breadth of the rectangle, so we're going to start with the first one as being PS, and that is going to be the square root of x squared plus x squared, because it's a Pythagoras theorem that we are applying. Then that gives us 2x squared, which can be simplified to root 2x. Root 2x. Then the length of PQ will be equal to, again applying Pythagoras, that will be the length of PL will be 50 minus x as well as LQ. So it is 50 minus x squared plus 50 minus x squared. Fortunately, we have two of the same brackets, so it's going to just be 2 50 minus x squared, and we can do exactly the same as on top. That becomes root 2, and the square root of a square is just 50 minus x. Then the area equals PS times PQ, which is equal to that answer, root 2x multiplied by root 2 50 minus x. And that's equal to root 2 times root 2 is 2x times 50 minus x. And that is, now you just multiply it out. So it is 100x minus 2x squared. And that is exactly what they want. 100x minus 2x squared. Right, hence determine the maximum area of that, show all calculations. Hence meaning that you need to use the previous answer. Now that was given, so if you couldn't do 11.1, you can still carry on with this question. So if they say determine maximum or minimum, you always must remember that you must do some calculus, because maximum minimum are found at the turning point of a graph, and that's the one method, or you can do it by completing the square. And we are going to do, for this one, we're going to do it with the first derivative of the area. Therefore, first derivative, now we have the area here. So, first derivative for 11.2 dA dx equals just 100 minus 4x. Now, since the derivative gives you a turning point, then you know that the derivative equals 0 at the turning point. So if you then solve for x, then you get that 4x equals 100. X is therefore equal to 25. So that is the value at which you will have a turning point for this graph, or at which you will have a maximum. In this case, it is a downgoing parabola, so it will be a maximum. Therefore, the area equals, where you substitute the x into the area value, so it's 100 times 25 minus 2 times 25 squared, and that works out to be 1250, and we have centimeter units, so it's centimeters squared. You can also do this sum by completing the square for the area. Therefore, remember that you need to have the coefficient of x squared equal to 1. So just to start the process for you, the area will be equal to minus 2x squared plus, and then it will be 100 over 2, because you're taking that out, which will become a 50x, and you can even plus 0 if you want to. Right, and then you complete the square on that. Thank you.